Hello, everyone. It's me, Billy Younger again. I thought I'd solve another different type of average velocity, or excuse me, in this case, average speed problem. I've seen a lot of different average speed problems in either being a student or being a teacher of physics. So I wanted to sort of give you all the different ins and outs of it. And also in the process, you can learn a little bit about how average speed's affected by time traveled versus distance traveled versus speed that you traveled over a certain amount of time versus distance that you traveled over a certain amount of time, that sort of thing. So I've created a problem that I think is kind of interesting, and it actually has two steps, and I'm going to show it to you now. Remember, you can find my videos at www.youtube.com/Billy Younger Physics Solutions, and that's capital B for Billy, and then a capital Y on the beginning of younger, like the opposite of older, then a capital P to begin physics, and then a capital S to begin solutions. So let's start by sharing the screen so you can see the actual problem that we're working. So in this problem we're working, it says you plan to drive 520.0 miles and you wish to do so with an average speed of 65 miles per hour. However, due to traffic, you only average 55 miles per hour for the first 260 miles. A, how fast must you average on your second 260-mile portion of the trip? And B, if you had averaged 55 miles per hour for the first 4 hours rather than for the first 260 miles, what average speed would you need for the last 260 miles? So those are the two major questions. I'm going to quickly on my iPad write down the key data, total trip. Again, this is a big part of physics, is just making sense of numbers they give you, or making sense and recognizing things that are implied, and giving them the appropriate symbols so that they match what you've learned about in your physics class. So in this case, the total trip, the total trip is 520 miles. So I'll say D. Whoa, got a really fat marker there. I'll say D total is equal to 520.0 miles. Yes, I know I'm doing everything in like miles per hour, but that's a more typical scenario when you're dealing with these types of things in everyday life. So I thought it'd be fine. And then, of course, your physics instructor, if they actually gave you a problem like this, they probably want you to convert it to kilometers per hour or meters per second or something like that. So total distance traveled is 520 miles, and you wish to average. So I'm going to say S bar wish is going to be 65.0. And I'm just going to write MPH again, MPH being miles divided by hours or miles per hour. However, due to traffic, we find that your average speed for the first, in this case, for the first, says, however, due to traffic, you only average 65 miles per hour for the first 260 miles. So I want to say for the first 260.0, and I'm going to set that equal to 55.0 mph. And this is about part A, so I'll put it next to part A. And they want to know how fast you must average on your second 260 miles. So S bar second 260 equals question mark. That's part B. I mean, that's part A. Then part B, it says if you would average 55 miles per hour for the first 4 hours. So I'm going to write B S first 4 hours equals 55.0 mph again. And the question is, what average speed do you need for the last? So I'm going to write S bar second 260.0. And it probably wouldn't hurt to put a MI by each of the 260s in my subscripts, just so we won't forget what they are. All right, so now I've written down all the numbers that I need. I'm going to stop sharing the screen for the problem and start sharing the screen for my actual iPad. So let me share that screen so you can see what I've written down, and hopefully that'll be somewhat similar to what you did. So I'm hitting share. Now I'm sharing the screen of my iPad. So you can see what I wrote down was the total mileage was 520.0 miles. I said that the average speed that I wished over the entire trip, of course, was supposed to be 65.0 miles per hour. In part A, I'm telling you that I averaged 55.0 miles per hour over the first 260. And I'm asking what what I need to average over the second 260. Part B, I said I averaged 55 miles per hour over the first 4 hours, and then I actually subscripted that erroneously, so let me erase that now. I want to know, you've probably done the math already, hopefully, but I want to know how fast I need to average over the second 4 hours. And what I mean by, you probably already figured that out, was if you take 520 miles and divide it by 65 miles per hour, I think you'll see that it comes up to 8.00 hours. So that's really what I made use of there. So let's start our solution. Our solution I'm going to write in green. So solution. I'm going to start with part A. And with part A, what I got to figure out is, okay, if I traveled at 55 miles per hour for the first 260 miles, how long did that take? Because in order for me to average 65 miles per hour, I think you can see that I'm going to need to travel 8 hours exactly. So let's first double check that. So if I set, remember, average speed is equal to distance divided by time. If I wanted my average speed to be 65 miles per hour, I'd write 65.0 mph is equal to 520.0 miles divided by time. And then, of course, I could solve for time by dividing 520 by 65. So that's 520.0 miles divided by 65.0 miles per hour. And that would give me T total, which means the total time of the trip. That should give me what I claimed was, in fact, 8 hours. So let's do it. 520. Oops, I already had something wrong. Calculate 520 divided by 65. And that gives me exactly 8.0. Now notice I had 4 sig figs in the top number and 3 in the bottom, so I really should call this 8.00, and then 1 extra digit, and I'll write hours. Notice what happened with the units. I had miles divided by miles per hour, but when you divide by a fraction, that's the same thing as multiplying by its reciprocal. So miles per hour in the bottom became hours per mile in the top, and the miles cancel out. And let this was just hours. So we do know the total trip time should take 8 hours if we wish to cover 520 miles with an average speed of 65 miles per hour. So now what we need to do is figure out how much time we've used by averaging 55 miles per hour over the first 260 miles, and then realize that the only time we have left is 8 minus that many hours. So let's do that. We know again that the average speed is equal to distance divided by time. So far, I've been sort of plugging the numbers in the equation where they go and then solving for the numbers. A lot of times we actually prefer to solve the equation and then plug the numbers in. I think I'll do that this time. In this case, what I want to know is how long. So I'm going to solve for t, and what I'll see is t is actually equal to distance divided by the average velocity. So the time taken for first, which I'll write a little differently this time, for first 260.0 miles is going to be equal to 260.0 miles divided by my average speed, which was 55.0 mph. Again, that's miles per hour. So when I divide miles by miles per hour, that becomes miles times hours per mile. So I get hours again. So if I take 260 and I divide that by 55, I get 4.7272. And it's always best to carry one or more extra digits. So 4.7272 hours is how much time I've used in my first 260 miles. I had 4 sig figs dividing by 3, so I really should only have 3 sig figs, so I should round it at 4.72. I'm just going to take and underline the second 7 and 2, and then everybody knows that that 7-2 is not significant. Okay, now that means all the time I have left, since we decided it was supposed to be 8 hours total to average 65 miles per hour, then 8.0000 hours minus 4.7272 hours is how much time I have left for the remaining 260 miles of the trip. So when I subtract 4.7272 from 8, I get 3.2727. Again, in this case, we had 8 was supposed to be to 2 decimal places, and 4.72 was supposed to be to 2 decimal places as well, which means really this should be 3.27, and then those last 2 digits are non-significant. So we have 3.2727 hours remaining for the 260 miles we got left. Let's now compute what that average speed must be. So finally, for part A, the average speed for the second, which I'm going to write again slightly differently just to save some space, for the second 260.0 miles, that average speed is in fact going to have to be 260.0 miles, and I'm going to have to divide that by 3.2727 hours. And when I do that, I say 260 divided by 3.72, and I get a whopping 79 point. Notice I'm dividing 4 sig figs by 3, so it should be 79.4. And then there's a long series of 4s after that, so I'll just underline that 4, and that's in miles per hour. So instinctively, we sort of think, hey, if you average 55 miles per hour over half the trip, and you want to average 65 miles per hour total over the trip, then obviously 55 is 10 less than 65, so we probably want to go 10 greater than 65 to make sure you average. But as you can see here, if I average 75 miles per hour, which is what 65 plus 10 is, I would not in fact average 65 miles per hour. That's the way average velocity and average speed behaves. It's distance divided by time. So the 2 distances going an averaging speed is not sufficient to make the speed what you want it to be. So that brings us to the second part, which is what is the average speed I'd need on the second part if instead I drove the first 4 hours of the what we need to be is a full 8-hour trip, as we've already calculated. What would the speed need to be on the second 4 hours? So let's work that out now. So that's part B. So in part B, what we want to know is if I drive the first 4 hours at 55 miles per hour, what do I have to drive the last 4 hours so that the whole trip will average exactly 65 miles per hour. So in order to do that, I got to figure out, with me driving 4 hours at 55 miles per hour, exactly how far do I go. Well, the formula for average speed is equal to distance divided by time. I need to know how far I'm going. So again, I've been putting the numbers in the equation and solving for the variable, but right now I'm trying to do it another way so that you'll get sort of used to this as well. And that is, I'm going to solve the equation first for the variable that I want and then plug the numbers in. So what I want here is I want to know how far will I go after 4 hours at 55 miles per hour. So I'm solving for distance. And clearly distance is equal to the average speed times the time taken. The average speed, of course, is 55.0 mph. Again, just easier to write mph than all that other stuff. The time is 4.0. And I never really explicitly said that, but I'm just going to treat 4 hours as if it has 3 sig figs. And obviously, if you take 55 times 4, you'll see that you get 220 miles. So that's how far I've traveled. Now the total trip actually has to be 520 miles. So I need to do the remaining miles, which of course is 520 minus 320, minus 220, which is 300 miles. I need to do that in the remaining 4 hours because, as we said before, to average 65 miles per hour, you have to do 520 miles in 8 hours. So just to verify, the distance we need to travel, D needed, is given by 520.0 miles minus 220.0 miles, which gives us 300.0 miles. Sorry, my dog's barking. So that's the distance we need to travel, and we've already used up 200, or excuse me, we've already used up half the distance. I'm trying to remember what I did. Oh, I've already used up half the hours. I already used up 4 hours. So now I need to use up the remaining 4 hours traveling this last 300 miles. So that average speed, which is what we're looking for. So S second, which I'll write again a little easier, more succinctly, for 4 hours. That average is equal to distance divided by time. I know, since I already drove, in this case, half the distance, excuse me, in this case, I know that I already drove, let me see, what did I drive? I already drove 220 miles. Now I've got to drive 300 miles, which is 300 plus 220 gives you the original 520. I need to do that 300 miles in 4.00 hours. So if I divide, I think y'all can figure out what this number is going to be to begin with, but still, if you divide 300 by 4, you get 75. And that's mph again. So it turns out this is more like what we expected when we were thinking about, well, half the trip is 55 and the other half the trip is 65, or you want the whole trip to be 65, so you expect to do 10 miles per hour over. That didn't work in the case where we actually drove half the actual in the first case. I'm trying to remember, sorry, my dog's got me all mixed up. In the first case, I drove half the distance. That didn't work, but in driving half the time, it did work. So in fact, what we got was our final answer, S average for the second 4.00 hours was in fact equal to 75.0 with an extra sig fig miles per hour. And that gave us in some sense, more like what we expected just on an everyday life sort of situation. So that's yet another problem involving average speed. Again, average velocity is very much the same type of calculation, except velocity is a vector quantity, and therefore we define the d a little differently. The d, for instance, doesn't have to be the distance traveled. In fact, the velocity, when you do the average velocity, you're actually going to calculate not the distance traveled, but your change in position, which is what we call your displacement vector. So if you want to calculate the average from time t1 to t2, you're going to take a vector that points from some arbitrary origin to wherever you are at time t1, and then you're going to take another vector from that same origin that points to wherever you are at time t2, and you're going to take that second vector pointing to you at t2 and subtract from it that first vector pointing to you at t1, and then that's going to be multiplied by the reciprocal of however long it took, and that'll give you a vector quantity. You can see, of course, if you ran, for instance, from home plate to first to second to third and then back to home plate, then both your your position vector at t1 and your position vector at t2 would both be the same vector, so you'd actually get an average velocity of 0 in that case. So that's sort of the major difference, and that's also one of the reasons why we are very, very hesitant as physics instructors to tell you that the magnitude of the velocity is the speed. It often is, but it's not necessarily. So hopefully that helps. Again, you guys ever need any of these notes, they're available. All you have to do is look in the comment section of the video, and you'll see some letters like PHY 241 and 01252023, which means that came from my physics 241 class on January 25th, 2023. And you can email me looking again at those comments for that email, and I can send you the very document that came with it. In other cases, it doesn't have a name like that, but it often has a date in it, or it has some other name that'll help you. So you can send me the actual title of the video, and I can send you again the PDF of the notes I took or whatever. I realize a lot of these earlier videos were done with a document cam and handwritten, and the bandwidth wasn't that great, so sometimes they came out a little messy, but I have all those documents, so feel free to ask for them. Hope that helps, and I hope to see you again soon. Bye-bye.